Welcome to another video from ExplainingComputers.com. For some time, the supply of Raspberry Pi single board computers has been limited, and earlier this week Raspberry Pi put out its latest news release about the situation. A few days ago I also spoke to Eben Upton, Raspberry Pi creator and chief executive of Raspberry Pi Trading, about the future supply of our favourite single board computers. Although, guess what, we moved on to other matters and had a fairly wide-ranging discussion about the Raspberry Pi. Greetings Eben, and thanks for joining us here on the Explaining Computers YouTube channel.
Well, thank you for having me.
We've both been part of this wonderful world of Pi for so many years, and we finally meet, at least here in video.
Yeah, well, it's lovely to meet. I mean, even in video, it's lovely. After the couple of years we've had, it's lovely to meet people.
Indeed. So we're mainly here to talk about the supply of the Raspberry Pi, and I know you've put a release out this week, and we'll come onto the good news in that in a second. But I thought it'd be good if you could just give the viewers here some idea of why there have been so many supply issues with the Raspberry Pi over the past few years.
Sure. I guess we're about 18 months now into what I would consider to be constrained availability of Raspberry Pi. The first quarter of last year, the first quarter of 2021, I'm starting to lose track of what year we're in. I think an effect of the pandemic has been that I'm either a year ahead or a year behind. But the first quarter of 2021 was okay. At some point in the second quarter of last year, we started to see sporadic shortages of some products, and then by the end of last year, we were then fairly thoroughly constrained across our entire product line. I guess we, like a lot of other people, have suffered from the global semiconductor shortage. This is really the result, I guess, of you can see it as a kind of from an electrical engineering point of view, it's kind of a ringing artifact. That what happened was, I guess at the start of 2020, the assumption was that there would be a large recession associated with the pandemic. You had people responding to that the way they usually do, which is to stop ordering product and run down their inventory to try to protect their businesses. Now, what actually happened was there was an increase in demand for electronic products because, of course, people wanted to work from home, or people were on furlough schemes, so they had their income protected. They weren't able to buy services. They weren't able to go out to restaurants. They weren't able to go on holiday. And so there was a displacement of constant income. There was a displacement of purchasing behavior from services to goods, and in particular to durable goods, to electronic goods. And so what you saw was, and it took a little while for people, us included, to notice that actually demand had gone up, not down. And then when you suddenly when those two things, you can't get back the fab capacity that wasn't used in 2020. And so the combination of that negative going supply shock and positive going demand shock generated a shortage. That shortage persists. The semiconductor supply chain was in any case very tight anyway. There was not an enormous amount of spare capacity. So it generates a mismatch, a shortage situation, which was hard to get out of. Of course, one of the problems, as we found out in other ways with toilet paper and hand sanitizer during the pandemic, is once the impression takes hold that there is a shortage, the shortage becomes self-reinforcing, and you start to see hoarding behavior. You start to see people's purchasing behavior change in anticipation of shortages, and that makes the shortages worse. So that's kind of what's happened across the whole semiconductor supply chain. It's affected some consumers of semiconductors more than others. Obviously, the car companies are probably the kind of the wildest example of a world in which a £20,000 piece of metal and plastic can be immobilized in a parking lot for want of a $1 engine management IC. So you've seen a lot of that. It's affected us a little bit, and we've worked hard to get around it. But I guess the good news is we are starting to see the light at the end of the tunnel, and I would say we have probably an 80% certainty that it's not an express train, that it really is the end of the tunnel.
Yeah, and the release you put out this week gave us quite a lot of good news. So could you sort of summarise the positive things that are going on?
Sure. I guess the biggest positive thing that's happened all the way through this is we've been able to sustain our OEM customers. So one of the interesting things that's happened with Raspberry Pi, we are a hobbyist, or if you think about our orientation, how we think about ourselves, the hobbyist in education, the enthusiast in education community is still really, really, really important to us. But as a share of our overall production, several years ago, industrial and embedded customers came to dominate our customer base by volume. When we talk about embedded and industrial, I think people think we're talking about huge, great multinational companies. So it's industry, but in fact, often we're not. Our customer base is notable. Our industrial customer base is not notable for being very wide and very flat. So we have an enormous number of 100-unit customers, 1,000-unit customers, quite a few 10,000-unit customers. We have very few 100,000-unit-a-year customers. And what that means is that these are often mom and pop companies. They are small organizations. They're small organizations that have invested in Raspberry Pi, that have put their faith in Raspberry Pi, and that will go out of business without access to the Raspberry Pi product. So to the extent that there's sort of good news about what's happened over the last 18 months, it's that we've been able to find ways, quite labor-intensive ways often actually, to sustain those customers. And therefore we are not in a position where we feel that the shortages of Raspberry Pis are putting people out of business, that there are people who can't pay their mortgages because we can't get them Raspberry Pis. We've been able to do that, and I guess the good news is we continue to be able to do it. We expect to be able to continue to do that over probably the 3 to 6 months of remaining sort of material shortage environment. So that's good news from our point of view. What's been the bad news over the last 18 months is that we have ended up having to deprioritize this enthusiast and educational customer base, which is kind of still the heart of the Raspberry. It's where the energy is where the excitement is in Raspberry Pi. And we tried to find other things. Pico, of course, is a real bright spot for us. We make our own silicon that hasn't been in short supply over the last year. And so we have had interesting new things to give that community. But to the extent that members of that community want to, say, be able to buy a Raspberry Pi 4, they haven't been able to so easily. I mean, you can if you get on a waiting list, but we don't want people to have to get on a waiting list. We want people to wake up in the morning, want a Raspberry Pi, and get one at 9 a.m. the next day. So that's been kind of the bad news. I guess the good news from Monday's release, the good news from the release that we did the other day, is that we are starting to be able to adjust that dial. In particular, we've been able to adjust that dial in the run up to Christmas. We've been able to put it about 100,000, a little bit over 100,000 units of a product into the consumer-focused reseller channel. And that's a bit of a mix. Quite a lot of the 3A pluses. 3A plus is a funny product because you can sort of see it as like sometimes described 3A plus as like a super zero. It's a $25 product, doesn't have Ethernet, only has a single USB. But it's pretty powerful, right? I mean, it's as powerful as anything we made before Pi 4.
I've always been a big fan of the 3A. It's a nice board, isn't it?
Yeah, I love it, and I sort of feel it's been an underappreciated gem, really. But one of the ways in which it's been underappreciated is it hasn't had a lot of industrial success. It is quite a hobbyist, ended up still being a very hobbyist-focused product. And so what we've done is we felt comfortable. A challenge if we put a 3B plus, which would be the obvious other thing we could build with the same piece of silicon. If we put that into channel, we'll tend to find that people find ways of hoovering the product that we try to give to enthusiasts. People will find scalpers, bots will find ways of hoovering that product and then making it available on the grey market to industrial customers. And we don't want there to be a grey market for industrial customers. We want to be speaking to our industrial customers, controlling. The way we're managing our way through this is, I mentioned hoarding behavior. It's very natural for an industrial customer, a small industrial customer who knows that they'll go out of business if they can't get Raspberry Pi, to want to hold safety stock. It's a completely justifiable thing to want to do, but it's a disaster, right, if they're able to do it. And so what we've ended up doing, we have active relationships with over 2,000 OEM customers at the moment, and what we do is we phone them up and we ask them what their true demand is, not indicated demand, true demand. What do you need and when do you need it in order to not go lines down? And so we manage everyone that way, and the existence of the grey market actually disrupts that process. So we don't want things leaking into grey market. Something like 3B plus does tend naturally to leak into the grey market, and therefore we felt comfortable to build a bunch of 3A pluses. We built about 50,000-60,000 3A pluses. We putting those into the channel because we know they're great for hobbyists. They're great for enthusiasts. So they'll be out there. I was just looking at RPi Locator this morning. We're big fans of RPi Locator. We think it's a wonderful way to keep tabs and just get early notice of whether device is available. RPi Locator is looking pretty good this morning for 3A pluses. We expect it will, on the basis of what we're putting in this week, last week, this week, and next week. We believe it will continue to look pretty good. So we've done about 50,000 units of that, 50 odd thousand units of that, about 20 to 30,000 zeros, I think, and about 40,000 Pi 4s at 2 and 4 gig at density variants. So we've been able to do that. And then kind of as we go through next year, Q1 is going to be pretty lean, actually. I think Q1 is, really not materially better than quarters that we've seen recently. A little bit better in some places, 2835 in particular, but really certainly across the kind of Pi 3, 3 plus, Pi 4 space, it's still a constraint quarter. Then Q2 is a pre-pandemic quarter, best part of 2 million devices we can build in Q2. But the problem, of course, is you've got backlogs. So you're gonna even though we're back to what would be an equilibrium, assuming we've not grown, which I think we may have done, but something that would be in equilibrium, a good quarter, will still require careful management because of the psychology associated with being in a shortage. Q3 onwards will be fine.
Yeah. So sort of April, May, June, you're getting back to producing a lot more Pis, but it'll take a while for people to get hold of them because of all the backlog issues inevitably come out of that.
So I think the two things people are going to continue to see in Q2, even though the underlying production environment is good, industrial customers will continue to see what we call active management, which is this business of asking people what their true demand is. Hobbyist enthusiast customers will continue to see quantity limits, and that's about avoiding the development of the grey channel. I mean, there's something enormously appealing to me actually about trying to stick the scalpers with a bunch of inventory at the end of the if I could just call it perfectly, just stick them with a few 100,000.
That's right at the right point. Yes, that
would just be perfect,
yes,
right?
Yes.
And who's to say we won't try and do a little bit of that? But because they've caused all of us a lot of pain and unhappiness over the last couple of years. But in practice, we're gonna continue to inhibit the grey market all the way through to this kind of Q3 nirvana, where we really have a lot of silicon.
Yeah. So it sounds like for the next sort of 6 months, the first half of 2023, the message is still go to official approved vendors, go that way, get on the waiting list, get hold of the boards via that channel.
Yes, and I mean that is kind of we've got to think about the positives as well that have come out of this. It's been a miserable thing for our customers. It's been a miserable thing for us. It's been particularly miserable for Liz and her team having to sort of explain to people the situation that we're in.
You want to sell pies, don't you? It's
yes,
that's why you're there.
No one gets into this business to disappoint a customer. I mean the most I absolutely understand a lot of the frustration that's out there, but the ones that I really struggle with are the idea that we're somehow engineering the situation, that this was design.
We don't want
situation.
to sell them anymore, it's can't be true.
I want to pump up prices even though we haven't adjusted prices really, but there's always that story that someone's able to come up with in their mind. This is you look at the people on the commercial organization, look at the people on the social organization, the comms organization, they want to be able to tell people good news. You look at the people on the commercial organization, they want to sell things and make customers happy. It's been obviously acknowledging that it's been extremely challenging for people outside our organization. Inside our organization, it's been very difficult because you're asking people to kind of cut against their, we effectively, I talk about active management. You're using salespeople to effectively do anti-sales. Where someone calls you up and says, I want to buy 1,000 Raspberry Pis. And you say, could you make do with 200? And then I'll give you another 200 next month. That's weird, right? So yeah, it's a, it's going to be good to be out of this situation.
Yes. I see from the release this week some of the prices have changed a little bit. Could you just run us through exactly where we're going to be or where we are?
Yeah. As an organization, we hate adjusting price. We actually hate adjusting prices in any direction. We hate cutting prices a lot because cutting prices is administratively very burdensome. But we particularly hate putting prices up. And we don't like putting prices up because, well, like everybody, we have, and this may turn out to be the end of an era, but we have a natural assumption that the cost of computing will go down rather than up. over time, and so certainly putting up cuts against the grain. The only pricing action that we've done so far until this week was we returned the 2 gig product to $45. So just before the pandemic, literally, I think the 28th of February, 2020, so our 29th of February, it was our 8th birthday. We discontinued the $35 1 gig Pi 4, and we brought the 2 gig down from 45 to 35. Now, what we did about a year ago was we unwound that. So we reintroduced the 1 gig product, and we moved the 2 gig product back up to 45, and that reflected some increases in cost in our supply chain. We also did a $5 increase on all. There are 32 variants of CM4. And the same price pressures that
so all the compute modules just went up the same amount.
They just went up. Not the older compute modules, not the CM3s,
no, right.
Not the CM1s, 3s, and 3 pluses, but all the CM4s. That entire product line, which ran from $25 to $90, went up to $30 to $95. Everything was shifted up by 5. So that's the only price change. Now, we've done what I hope will be our only remaining price change this week, which is we've adjusted 0, because I mentioned we're expecting 2835 base product to be a little more available, but its cost structure has degraded. And so we've ended up doing the $5, $10 point for 0 and 0W was always extremely marginal. And so what we've done is we've moved those up to 10 and 15. That recovers the cost increase. But it also frees us up. There have always been volume constraints associated with 0, because it has to fit into spare manufacturing capacity. What this price adjustment lets us do is it lets us kind of open the taps and treat 0 like a real product, like a regular product, rather than a capacity filler.
So it sounds like we'll be able to get, once all this is worked through, more better access to the 0. So what was it? So $10 for the standard 0 and 15 for the 0W.
15 for the 0W. Of course, that's interesting because it means that 0W and 02W are now the same price.
I was about to ask you that. Yes.
Yes. Well, I mean, remember that historically it's our custom to make every product the same price as its predecessor, and kind of you can feel that we've got there by a roundabout route here. It's not the route we'd like to have done. We would have liked to have done 02W at 10, but it's at least consistent. 02W is, I mean, of course, one of the challenges with 02W is it's not in a great deal of production at the moment. We're producing less than 100,000 units a quarter of 02W, which is massively out of alignment with what we think the underlying demand for that product is.
It's a fantastic board, isn't it? It appeared just as it started to disappear almost, didn't it? And it's
it was and a number of things happened that kind of killed the launch and early volume of that product, and that really sucked. I think it is another cost. It's not as hard pressed on cost as 0 and 0W were, but it is hard pressed on cost. I'm not sure we could accommodate, not expecting any further degradation in cost structure, but I don't think we could accommodate any degradation in cost structure on 02W without having to increase its price. There is a natural space there's a natural price point at $20, which is separate both from 0W at 15 and 3A plus, which, as I described, is a kind of a super 0 25. But I think, to the extent we can, I think really the aspiration is to keep it at 15, and we'll work very hard to do that.
Yeah. Well, that seems all very clear. I'm sure people will be really pleased to know all that. Can I ask you just a few broader questions as I've got you here? One is, we've talked a bit here about industrial customers and smaller businesses using the Pi for their product. And this often comes up on the channel in comments. People are saying, well, what are people doing with these? And so I just wonder, could you give us just some examples of the sort of things that Pis are going into in terms of products? And
Sure. I mean, it's all industrial stuff. Give you examples. Car chargers.
Oh, right, yeah.
Lot of electric car chargers run on Raspberry Pi. Digital signage. Obviously, there were these things which were kind of the original spikes for Raspberry Pi. Because remember, Raspberry Pi doesn't have a huge amount of CPU performance, but it has enormous amounts of multimedia performance. So you have places where that was a benefit. So digital signage, thin client, which is effectively, I mean, a thin client is kind of, you can see like a Citrix thin client as being effectively a video player on your desktop. It plays you a video of a Windows desktop which is running somewhere else. So those are pretty popular. Generic industrial automation. So yeah, we have a number of partners, including Sfera, in Italy and Combus in Germany, who build industrial computing platforms around a Raspberry Pi. So it's effectively a Raspberry Pi or a compute module based board that fits onto a DIN rail, fits into an industrial enclosure that fits on a DIN rail in a factory and does all industrial automation applications. Some really nice ones, things like occupancy sensing, obviously sort of smart building management, occupancy sensing, foot traffic counting for retail, audio players for retail. Actually, one of the things we discovered when we brought the IQ Audio family of products into Raspberry Pi was an entire ecosystem of people who were buying Raspberry Pis and IQ Audio accessory boards and using those just to play music in shops. So this is very, very kind of very broad thing. Obviously, a lot of things where people are a lot of things where people are exploiting the physical interfacing capabilities of the platform, which is really where it stands out, or the multimedia capabilities of the platform. But yeah, we also see, I mean, we've seen some interesting supercomputing applications. People who if you run a supercomputer, it's an interesting problem. If you run a supercomputer, modern supercomputers tend to be white box supercomputers, so it's a lot of generic Intel hardware with some interesting fabric stitching it together. If you run something like that, you want to train people, you want to be able to train operators, train programmers to take their problems and partition them across, write them in ways which allow them to be partitioned across this kind of infrastructure. But what do you train them on? Because your supercomputer is pretty busy doing supercomputing things. Think of a supercomputer. Well, you could use the previous generation supercomputer, but the previous generation supercomputer consumes like a megawatt of power, multiple megawatts of power. You don't really want to be running that. You'd rather scrap that. So we have from time to time had this little kind of business in building kind of bijou supercomputers, training supercomputers where the Raspberry Pi has less performance than a supercomputer node, and you can connect it if you connect a bunch of them together using generic off-the-shelf Ethernet fabric, then you end up with a fabric which has less performance than the supercomputer fabric, but everything is kind of just scaled, everything's scaled down, and you can learn the same lesson. So you have a few of these kind of weird.
That's a fantastic example, isn't it? That really is.
Yeah, and it's I like it because it's sort of. It's only using the compute capabilities of the platform. It's not actually using any of the spikes, any of the the physical interfacing or the camera stuff or the display output stuff. It's just using the compute in the platform, and obviously not a lot of these have been built in the last couple of years because it is hard to persuade us to part with 10,000 Raspberry Pis for one customer for that sort of application.
That's fantastic. And a couple of final things, because if I don't ask them, people will ask, why didn't I ask them? One is technology. I've been emailing back and forth the past few days with companies who are starting to release RISC-V based single board computers. We're seeing boards now. I think the Vision 5.2's got a quad-core 1.5 gigahertz board. So it's getting towards the power of a Pi 4, and it's about the same sort of price. And this obviously gets me towards, will we ever see RISC-V in terms of Raspberry Pi? Is it something that you think will ever happen?
I would never rule it out, but I would say that people need to be very realistic about the advantages that the ARM ecosystem has.
Yeah.
And how comparatively little money it costs you to take advantage of those. To take advantage of those advantages, to participate in that ecosystem, you have a platform with very mature compiler technology, with very mature operating system support, with very mature middleware support, with very mature application support. So, people have spent a lot of time making sure that the JavaScript runtime in Chromium, say, runs very well on ARM 32-bit legacy ARM and 64-bit modern ARM cores. So you have a lot of ecosystem advantages. You have very ready access to very, very high performance cores. Now, I'm not aware that today I can go out and license even a RISC-V core, which is competitive with A72. Which is what we have in Raspberry ARM Cortex A72, which is what we have in Raspberry Pi 4. So you're still some distance. And if you were to go out and license such a thing, well, these are enormous. I have a reasonable idea of how large a project developing a A7 class, an A70X class core is, and it's a few hundred engineer years of work to do it, assuming you're already holding in your hands the previous one, right? So it's not even like that's from a standing start. That's a team that have done it before, have access to the RTL for an existing core. Maybe they'll throw it all away. They do periodically throw away all the RTL they have and design something new from scratch. But at least you will have that to look at to understand what you did right and what you did wrong, and you'll have a bunch of engineers who've already done the work. So it's hugely expensive to do. And so to the extent that RISC-V cores in this class appear, they will have been expensive to develop. Because they've been expensive to develop, they will have to be expensive to license, because no one's doing this stuff for free. There are no free. There's a lot of free microcontroller class RISC-V cores around, but there are a lot of free A class, even A7, A53, well, A7, even A7 class cores just aren't there. So there's a kind of you have to work pretty hard or reach for some kind of geopolitical argument or market structure argument. I mean, I think if NVIDIA had been successful in acquiring ARM, that would have changed the rules of the game very substantially. I mean, would you trust Jensen not to take advantage of owning the ARM architecture? So that would have changed everything. And there are other things that might happen. It's interesting. Qualcomm have got some wild allegations in their lawsuit with ARM at the moment about ways in which the ARM ecosystem might change. And some of those ways would provide an advantage to RISC-V, even in a world where you have to pay ARM-like license fees to get your hands on a high-performance core. But until then, I think there are more opportunities in microcontrollers, actually, than there are in A-class, just because there are more cores available. Some of those software ecosystem benefits are less pronounced in, you don't have a web browser and it's JavaScript JIT to worry about. You don't have thousands of accumulated engineer years of optimization in pixel blitting libraries to worry about. So that might happen. But A-class, I'm skeptical. I absolutely wouldn't rule it out. But it'll be an external thing that comes in and forces us all to change, rather than being us waking up one day and saying, "Yeah, we want to jump ship."
It sounds like you're saying not never, but it's not on the near horizon at all. It's
So something, as I say, something would need to change in the structure of the industry. And if ARM continued to offer the things that ARM offer, I would be at the same sort of prices and on the same sort of terms that they offer them. I can't understand why you would wake up in the morning and
suddenly go, let's change our architecture.
Why would I license this core when, things like A55, Cortex A55, Cortex A, or most of the 7 series cores, they're all pretty good. Right, they're really good, and they're not insanely expensive to get your hands on. So I don't know why I would choose something else.
That makes perfect sense. And finally, and you probably can't answer me this, but what about the future of the Pi? Are there new models on the horizon?
Some way over the horizon?
Yes, that's right.
Look, one of the things that's... I mentioned it back at the start, didn't I, that it's been a weird couple of years, and what's it done? It's kind of disrupted our cadence a little bit. I mean, you can sort of feel that there's a cadence associated. So both the pandemic and then the shortages after it, they've disrupted the cadence with which we develop new work with partners to develop new platforms and then work internally to turn those platforms into Raspberry Pis. So it isn't the case. So Raspberry Pi 4 has been around for 3 and a bit years now. Now we've posted some performance uplift. Obviously, we posted the 1.5 to 1.8 gigahertz, people obviously are finding there's still a lot of overclock ability margin, even over the 1.8 gigahertz point. But it is a platform that's been around for longer than any Raspberry Pi platform has been around before, I think. So 1 lasted nearly 3 years. 3 and 3 Plus together lasted for about this long. So 3 lasted for 2 years, 3 Plus lasted for a year and a bit. So it is a product that's been around for a while. On the other hand, we've, as I say, we posted some clock speed improvement. We've also posted an enormous amount of software optimization and, as you know, energy optimization as well. One of the big challenges early on with Pi 4 was energy consumption, and we've made that much better. So I think we are. Don't expect a Pi 5 next year. I think would be the next year is a recovery year. So on the one hand, it's kind of slowed us down. On the other hand, it's slowed everything down. And so there's merit, I think, in us spending a year before we look at introducing anything new, spending a year recovering from what just happened to all of us.
That sounds like a good idea, both from the point of view of the company and all the individuals involved as well, isn't it? Let's just get back to some sense of normality.
Yeah, particularly if, what would really be a disaster would be if we tried to introduce some sort of Raspberry Pi 5 product, and you referenced 02W, if we introduced some Raspberry Pi 5 product and it couldn't ramp properly because of constraint, or if we introduced some Raspberry Pi 5 product and it somehow cannibalized some supply chain element. And remember, this isn't all about, these shortages are not all about, so there's an assumption that a Pi 5 would need to be on a new process node. So you might say, well, how does that cannibalize the existing wafer supply on 28 or 40 nanometers? But you've got to remember, these shortages aren't all about silicon. Some of them are about packaging, some of them are about test capacity, some of them are about substrates. And so the other thing that would be disastrous would be if we found that we were cannibalizing the recovery of Pi 4 or recovery of Pi 3 or 3 Plus by doing this. So I think we're going to be very ginger about how we look to move forward. But the good news is, I think, certainly the second half of next year, 2024 onwards, some of those things start to abate, and that's the point where we can start to think about what might be a sensible Raspberry Pi 5 platform.
Well, that seems, I think, a fantastic point to end this. Thanks greatly for your time. I've enjoyed talking to you, and I'm sure the viewers will have enjoyed hearing what you've had to say.
Wonderful. Well, thank you again. And like I say, it's really, really wonderful to virtually meet you for the first time in really several years of working together with you guys. Thank you.
That's brilliant. Thank you very much indeed. Thanks, Eben. Take care.
So there we are. Thanks greatly to Eben for that interview. Lots of things to think about in what he told us. I hope you found it as interesting as I did. But now that's it for another video. If you've enjoyed what you've seen here, please press that like button. If you haven't subscribed, please subscribe. And I hope to talk to you again very soon.